Hi, it's Charles again. In this video, we will do the simulation in Fluent. We would assume you already have mesh files generated with TurboGrid. To start, let's launch Fluent as a standalone application. Fluent. Let's use single precision for speed for now. For the processors, use 8. This heavily depends on your computer's CPU. The working directory, let's change it to October the 5th, since that's the one we are using. Okay, select folder, start. Okay, once the Fluent is ready, let's enable Turbo Workflow. The overall setup process is really just walking through those tasks one by one. Let's start by describing components. We are doing a radial compressor, 2 rows, 1 stationary, 1 rotation. The number of sectors should match your design. We have window wall gaps for impeller, no window wall gaps for diffuser. The second step is, do we want to include everything in this specific simulation? Yes, we do. Now we can import meshes. They are in the user files, impeller and diffuser. Once the mesh files are imported, you should be able to see all the inlet and outlet regions. Now let's associate the meshes. For the impeller, sometimes you need to uncheck the use wireframe for highlighting in order to actually see the highlighting. Well, no, it's not even showing the highlighting. Okay, that's inlet. Apparently missed out the one passage inlet. Okay. Oops, that's a little bit too inlet and okay, that looks good. Then it's the stator. That would be inlet plus passage. That looks good. Okay. Once the mesh file is associated, we need to map the specific regions. For the rotors, hub, shroud, that looks good. This is the inlet region of the impeller, so no blades. The inlet is apparently wrong. The outlet, periodic 2, periodic 1. Okay, that's the inlet region. Now the rotor, impeller, hub, shroud. Normally the blades are wrong and the tips are wrong. Let's fix that. The tip, you wanna do blade tip shroud GGI side 1 plus the splitter blade, same thing. And for tip 2, you want to do side 2 for both impeller and for most main blade and splitter blade. Okay. That looks okay. Just redo it, make sure I select the right thing. And then for the blades, you want to include everything that have geo in there, plus the tip, plus the trailing edge. And same thing for the splitter blade, or everything have geo, plus tip, plus trailing edge. Okay, that's good for rotor. For the stator, same thing, hub, shroud, inlet is wrong, outlet, periodic 2, periodic 1, It's good. And same thing for the stator. Hub shroud, blade. Is that everything for the blade? That looks right. Inlet, outlet, periodic 1, periodic 2. It's good. Now we can map all the regions. Everything looks good. And now set up the CFD models. The rotational axis is apparently Z. And then we can estimate number of sectors to do a sanity check. That's 9 and 11, matches our design, looks good. Now the diffuser, this section is misaligned with the impeller section. It's perfectly fine for the simulation as we have the periodic boundary condition. But for later, the post-processing for analyze, it would be really beneficial if they can align somehow. So let's do some alignment. That looks not bad, but we can align better. Okay, that looks good. So create CFD model. Now the rotational speed, it might be a tricky part because if you look at this, the rotational is actually in the right hand rule. So if we want this impeller to rotate correctly, we should use a negative rotational speed. We can change angular velocity units to RPM and then set it to negative of what we have in mind. For example, this one I have 90,000 in mind. And cool. Then we can use pressure inlet and pressure outlet. I think this is recommended for the compressible flow simulation. The inlet is 1 atmosphere pressure, no problem. The outlet, when we tell it should use the one you have in your preliminary design file. For now, let's use roughly 4,000 psi. 400,000 psi, and we should be good. It's setting up all the boundary conditions for you. And the fan of the computer is running really, really high right now. Okay. And now it's defining turbo topology, turbo ISO surface, and reports and monitors. If you did all the previous steps correctly, those should generate without problem. If there is something wrong, you probably want to go back to associate mesh or map regions to correct the error. Let's do it now. It's no problem. And the ISO surface, that looks okay. And then the reports. Okay, looks okay right now. It says the initialization is not very happy because the scalar is above the tolerance, convergence tolerance. We can go into solutions for the initialization. We can let it iterate a little bit more times and reinitialize it. Now we are below the tolerance threshold. We're good. Since Fluent is not very happy from time to time, it's always good to save your case file into somewhere safe so that if it crashes, you have somewhere to pick up. Let's say compressor. Now the case file is saved. Now we can actually do the simulation. Let's do 100 and calculate. You can view those specs in real time. and see the residuals. That's all for simulation. Thank you.